So I'm going to say there are basically three different cases here. If we're working with formulas, then there's a possibility we can evaluate the limit just by plugging it in. There's another possibility, which is that we can not plug it in, but we can do it with algebra. And then the third situation is we can't plug it in, and there's no way to do algebra, so we have to use a computer or calculator to get at it. The ones where we can just plug it in are kind of obvious. They're the functions that seem really nice, and they're staying away from any potential problems. So an example of something like this would be the limit as x approaches 3 of 5 times 2 to the x plus pi. There's no reason here that you can't just plug this in. It's basically an exponential function. So in that case, no reason not to just go 5 times 2 cubed plus pi. And if you have arbitrary constants or other things that might make it seem like it's messy, as long as the function is nice enough, it's really not. It's really not messy. So as an example, we could look at the limit as x goes to 1 of qx plus 5. And is there any reason here that I can't just plug in x equals 1? So I can just plug in q times 1 plus 5, and I get q plus 5 as the final answer. This works even if there are situations where it might not look. One of the things that freaks people out is looking at when we have a divisor, when we have a denominator. So if you look at the limit as x approaches 0 of 2x over 3x, what can I do here to make my life easier? Cross out the x, thank y'all. Because this is just too easy. So then we have the limit as x approaches 0 of 2/3. And now this piece doesn't depend on x. So now the answer is 2/3. Well, what people will do is they will get really squirrely about that because the algebraic situation might be uncomfortable. And so they'll start to worry about that in situations where it's not necessary. I could look at the limit as x approaches 10 of 2x over 3x. And is it wrong to cancel here? I would say it's wrong, but you don't need, you can just directly plug in 10 because there's no reason you can't. And I would be perfectly happy with this as a final answer. Of course, you're probably going to recognize, wait a minute, I could have canceled those 10s and just ended up thirds, but that's not super important for this discussion. The important thing here is there are times where you would need cancel, and then there are times where you don't. And it's determined by whether or not you're trying to avoid dividing by 0. If you're looking at the limit as x approaches 0 of 3 plus x squared minus 9 over x, the first thing you might try to do is if you plug in 0, you might see, well, will that work? So when I plug in 0, I get 3 plus 0 squared minus 9 over 0. And this divide by 0 says I cannot evaluate it this way. It was worth trying, but it just didn't work. So how would you recommend that I proceed? But I like writing it out that way because it helps us avoid some common mistakes. So now notice we're doing algebra first, and then when we do the algebra here, we get 9 plus 3x plus 3x plus x squared minus 9 all over x. But let's keep going with this idea. Let's say I have the limit as x approaches 0 of 9 plus 3x plus x squared minus 9 all over x. Okay, so 9 minus 9 cancels, and that becomes the limit as x approaches 0 of, can I do these 3x's together too, right? 3x plus 3x is equal to 6x. So now I have 6x plus x squared over x. But can I do anything else? What we need to do is factor out the x. So here I'm factoring out an x, and then I can cancel it. Now I can cancel. And after I cancel the x's from top and bottom, I'm left with the limit as x approaches 0. Now there's nothing that's keeping me from plugging this in because I have solved my divide by 0 issue. So I have 6 plus 0, which is 6. So at the end of the day, my conclusion is that the limit as x approaches 0 of 3 plus x quantity squared minus 9 over x is equal to 6. It required a fair amount of algebra to reach that conclusion. And there's sort of a meta idea here which is